All right, so for our next question here, we see that we have um, a quadratic function stated in its canonical form, and we're told that the discriminant b squared minus 4ac is greater than 0. So what that's communicating to us is that we do have two distinct real solutions for the function of the quadratic function equaling 0, which means we do have two separate x-intercepts. So with that being the case, we know if we have it in the form of a times x minus r1 times x minus r2, we know that r1 and r2 represent the x-coordinates for the x-intercept. And so what we're asked to start off here is we need to find a quadratic function whose x-intercepts are at -4 and 2, and with these values of a. So if we start off, we'll see that when a is equal to -4 here, so I'll go ahead and erase that. When a is equal to -4, sorry, when a is equal to 1, excuse me. Here we know that if x equals -4 is an x-intercept, then x plus 4 is going to be the corresponding factor. And so we know that by doing this. So our a is going to be 1. And if we're following this formula here, that would be x minus r1, which is a -4, times x minus r2, which is 2 there. And so we know that subtracting negative is the same as addition. So we end up getting x plus 4 times x minus 2. And if we FOIL that out, we end up getting x squared plus 2x minus 8. And so if we move on to a is equal to 2, then what's different is here instead of it's being multiplied by 1, now it's being multiplied by 2. And so that would just be 2x squared plus 4x minus 16. If a is equal to -2, then of course all is the same up here, except for now everything is being multiplied by a -2, which will basically change the signs of this one. So we'll have minus 2x squared minus 4x plus 16. And then if a is equal to 3, and of course all else is the same. It's up here except for now everything's being multiplied by 3. So that'll be 3x squared plus 6x minus 24. Okay? Now, notice that in all these situations here, everything is still of the form whatever the a is times x plus 4 times x minus 2. Okay? So we'll go ahead and put these answers in, make sure they're correct, and then we'll move forward. All right, so we see that all these end up being correct, so we'll just go ahead and move on to the next part of the question. And so the next part of the question asks us, how does the value of a, which is the leading coefficient, how does it affect the x-intercepts? Okay, so to look at that, I'm going to come back here. And so if we see that the only difference here with the a is that it's being multiplied outside of what's going on here with the factors. And so in general, what that means is this. And let me clear some of this out of the way so that I can be clear here. So we know that we can write this as y equals a times x minus r1 times x minus r2. And regardless of what a is, we know that our x-intercepts is always going to be the point r10 and the point r20, no matter what a is. So our x-intercepts are not affected by this. Okay. However, our y-intercepts will be, because of course, when we multiply all this out, you'll see that all of our values for c in the general form of a quadratic function changes. Of course, this value c here is directly connected to what the x-intercept is. And if you look at our answers for the previous portion of this problem, when a is 1, our y-intercept is -8. When it's 2, it's -16. When a is -2, now it's +16. And when a is 3, now our y-intercept is located at -24. So we know that our x-intercepts won't be affected, but our y-intercepts will be. And so if we pick B, let's see, value of A does not affect x-intercepts, but we'll change to y-intercepts. I think that's the one we should pick. Okay? All right, so let's move on. So it says, how does the value of A affect the axis of symmetry? Okay? Well, let's go ahead and clear this, and let's take a look at that. So let's clear this. If we go back to what our formulas for H and K were, we see that H is minus B over 2A, K is 4AC minus B squared all over 4A. And so if you notice, the axis of symmetry is directly affected with H, which has a direct connection to A. So if A changes, the axis of symmetry changes. So we know that it's going to change, so we just need to figure out how. So if we look at our answer choices here, the value of A rotates the axis of symmetry by 90 degrees. The value of A does not affect axis of symmetry. That's not correct. The value of A shifts and rotates the axis of symmetry, and the value of A shifts the axis of symmetry horizontally by A units. So if we look at our answer choices here, before we start to investigate some, we can go ahead and rule out some of these answers. By looking at this, answer A and answer C would not make any sense. And the reason for that is as follows. So if we look over here, if we were able to rotate or shift and or just rotate period, then our parabola, which in this case, let's suppose that the parabola is turning up like this. If it rotates, then let's say it rotates this way, or it rotates and starts going this way. Now, our parabola has now just turned from something that was a function, meaning it passed the vertical line test, to something that is not a function. Okay? And so we would not be able to state quadratic function of the form and have all these questions if our parabola now turns into something that's not a function. So we know that A and C are definitely out because of that. Okay? So now it's just a matter of will the value of A shift the axis of symmetry. And so if we look at that, we'll see that minus B over 2A is what axis of symmetry is. It looks tempting to answer that. So, but what we're going to find out here is that B is actually the answer. And so we'll actually do some empirical analysis and see why that is. So I'm going to go ahead and clear this up. Now the main reason is because if we look at how we changed our A and our B here, if you notice, A is 1, B is 2. And so here we have A is 2, B is 4. So it changes by the same factor. So because both A and B are changing by the same factor, whenever we change A here, that means that the axis of symmetry should not be affected. So to see that plainly, let's look at a few of them. So for when A is equal to 1 here, we'll see that x is minus B over 2A. So we have a minus 2 over 2 times 1, which is a negative 1. When a is 2, we'll see that when we do this, we have a minus 4 divided by 2 times 2, because 2 is a, and of course that's still negative 1. If we do a is negative 2 and do it all over again, then we have minus a negative 4 divided by 2 times a negative 2. And so, cleaning up this particular 4 here, you see that negative divided by negative is positive, and 2 times 2 is 4, so we still end up with negative 1. So you see, and you'll see the same kind of thing going on if a is equal to 3 here. So answer to this next question here, which is how does the value of a get affected by the axis of symmetry? A does not affect it at all. Okay. So if we go on to question B, so how does the value of a affect the vertex? Okay. All right, so how we're going to look at figuring out the answer to this particular question is we'll go back and look at our formulas right quick. And so if we look here, we see that k is equal to 4ac minus b squared all over 4a. So what we see happening here is, let's say if in this case a is just equal to 1, then we know everything just stays par. So we know that k is equal to 4ac minus b squared all over 4a. But if a is now equal to 2, then that's going to be 2 times what we see here. So in this case, if we were to let k now be equal to 4 big A, big C minus big B squared, all divided by 4 big A, where big A is 2 times little a, big B is 2 times little b, and big C is 2 times little c, because we know that whenever we come in and multiply a through by everything here, everything is going to be increased by a factor of 2 there. So we're guessing that the y coordinate for the vertex will be raised by a factor of 2, but we're going to plug this in and see if that actually works out here. So if we plug all this in, we get the following. All right, so if we let big A equal to little a, big B equal to big B, and big C equal to little c, we plug all that in and we see that what the result ends up being in this case when we let a equal 2 is that our k ends up being 2 times what we originally started with here. So what this tells us is that if we change a by a factor or multiple of 2, then that means that our y coordinate for the vertex will change by a factor or multiple of 2. So a is affecting the y coordinate for the vertex by a multiple of 2 here. So we'll see that vertex, I think this one would be the value of a does not affect the x coordinate of the vertex. However, it does affect the y coordinate for the vertex. So choose that one and see if it is right. Yes. All right. And so we'll continue on. It says, compare the x coordinate of the vertex with the midpoint of the intercepts, and what might you conclude? All right, so drawing out what they mean here, we know that the axis of symmetry sort of splits up this particular function in half. And so the x-coordinate for the vertex and the midpoint of the x-intercept, so here the x-intercepts are here and here, and that means that the x-coordinate for the vertex will be halfway in between. So thus what that means is the mean is going to be, mean of the intercepts is going to be the x coordinate for the vertex. So that concludes our video.